Well, good afternoon, everyone. Welcome to our webinar today, Creo Flow Analysis, where we're going to take a closer look at a newer CFD tool from PTC that works very well with Creo. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And joining me today are Paul Dye, Application Engineer from PTC, who's going to give you a brief presentation on Creo Flow Analysis as well as a demo. And also joining us is FEA and CFD expert Bill Stickney. And Bill will assist us with answering any questions and also giving some good commentary on Creo Flow. So we hope to have this webinar done by 12:30, keep it within a half an hour. If you have any questions, please type them into the dashboard. We'll try to answer them as we go, but we will definitely answer all questions at the end. And everybody will be on mute during the presentation. What I want to do first is I want to ask everybody a quick question. Basically, just a quick poll to see what is your current state in running CFD or CFD tools. So, you know, do you currently have a specialist on staff? Are you outsourcing your CFD needs? Or are you in a situation where you'd like to have a tool that your designers can use? Now, there isn't just one answer here that you can check. You can check multiple answers if necessary. Or is CFD something new to you guys? So as a company, I mean, we want to be consultative and help our customers solve problems, which is what we do. We do it better than any other PTC reseller, especially in the areas of FEA and CFD, which is a credit to Bill Stickney. So anyway, thanks a lot for participating in that poll. And what I'm going to do is I'm going to switch everything over to Paul and give him control. There we go. Paul, you have the con.
All right. Let me share up the proper screen here. Let me see.
I think most people work off of 2 or 3 screens on a daily basis.
Yes. So let me share the proper screen here. And do I have the proper thing shown right now?
No, you're showing the invitation to Creo Flow Analysis.
Perfect. I don't work with this one too much, so let me pick where we got. There we go. Should be looking good now.
There we go.
Awesome. So thank you for hanging with me there. And hello to everybody on the line. And again, my name's Paul Dye. I'm with PTC out of our Virtual Center of Excellence, and I work with everything Creo. And so specifically in today, we're going to be talking around Creo's flow analysis tools. And so just to start off, giving some context into the tool itself, I want to go over first some of the different challenges that really this tool looks to address. So when we're looking into fluid dynamics or CFD, it's typically seen as something that really requires extensive training or knowledge that engineers in general just tend to lack. To even run this type of analysis requires often the use of third-party tools that are oftentimes not only very expensive, but also very hard to use. It's because you have to take the models from your CAD environment that you're working in, export them out, and then have somebody that has knowledge on how to use CFD to even begin an analysis. And so it becomes really a very time-consuming process from start to finish, which tends to make this process only viable in the later stages of the design. That's because in the development stages, your models are in a constant state of change, and you can't really wait around to get that analysis result back. What this leads to is a thing like over-reliance on physical prototypes, because you need a way to actually go through and verify the designs. So this again tends to occur later in the development cycle and can really be very costly if you're going through multiple different iterations. So this reliance causes projects to be delayed or maybe even come in over budget. So obviously things that we need to avoid going forward. So all these different challenges are things that we set out to solve with the flow analysis extensions within Creo. So the goal of this is to take those fluid dynamics capabilities and put them in an easy to use tool right within the CAD environment. So no more heavy reliance on late stage prototypes or other verification techniques. Make this part of your early stage design process. Really get those results back early and also often. So we built this tool really to be utilized by everybody. So not just the expert or the flow analysis specialist, we want the designer to be able to work with this extension and actually build it into a part of the overall design process. And so this workflow between design and CFD and Creo really is seamless. So compared to your normal process of working with a third-party system where you could have issues switching back between your CAD and your analysis environment, we've really broken down the barrier between those two different worlds, between your design and your for one system and then analysis in another. It's one more unified analysis-driven design environment that we're working in. So we also have very easy flow model creation. So for example, here we have the ability to tell the system to generate the mesh for our analysis. So it's automatically done for us. We don't have to go through and manually define that all ourselves. And so we do still have the ability to make the mesh more defined in any areas where there might be more curves or just more complex surfaces, and in areas with more simple flat geometry, and expand that mesh out a little bit to make it run fast. So along that train of thought, this tool has a very quick turnaround for getting those simulation results. So it's no longer shipping off our models to get results back in hours or a lot of times even days. Let's run that analysis ourselves and still get the results back in a much faster manner. And in conjunction with that speed, the results that we're getting back are still very highly accurate. So we have many different ways of viewing the results, including taking section views of the model, creating XY plots, viewing isosurfaces like we see on the screen there. And then with this, not only getting results, but getting into a form that actually provides us with insight rather than just a large sum of data that we have to sort through. And so to get a better understanding of that, I'd like to take us through a little bit of a demonstration here working in the context of Creo. Right, so for our demonstration of the flow analysis extension, we're going to be working with our Polaris snowmobile data set here. So specifically, we want to get more information on a heat exchanger that we have working inside. So we can simply open up that part and we can get to work. So you can see that we have some good geometry that we'll be able to utilize for our study. And so we know that we're going to have water moving throughout this heat exchanger. So let's go through the process of setting that up. So if we want to do that, the first step is just going to go up into the top into our applications and select the flow analysis tab from that command ribbon. Once we're in there, we'll begin into a new project and lay out our fluid domain. So the fluid domain is the boundary of the simulation. It means that all the fluids within the study are contained within that 3D space that we define. And another thing that we can do is lay out a surface set that tells the systems exactly where our openings are located. In other words, where the fluid is either entering or leaving the system. And after we've laid out that fluid domain, there's obviously going to be parts within the model where the fluid is not going to be flowing through. So here we can just go through very quickly, tell the system which parts of the model should be treated as solids and excluded from the fluid study. And so here we can see a lot of our different options for our materials as well. So a lot of options to go through, lay out any gases, air. In this case, we're just going to be working with the water for this heat exchanger. And also with that, we're going to define that as an aluminum. And next, we have our different components that we can select through the physics modules that we want to utilize. In this case, we're going to be working with some turbulent properties along with some information on heat and also streamlines. Right. After this, we'll then take a closer look into some of the conditions for our analysis. So for our study, we want to see what our minimum and maximum temperature values are going to be. We also have the option there to plot out our results, which we'll see more of in just a moment. Right, the next step that we want to take a closer look at is at our boundary conditions. So let's zoom in very quickly in on our inlet pipe. We can go through now, enter in some of the values that we want to observe, such as say the inlet flux and the temperature there. Right, many different parameters I can change there, really tailoring the analysis to the exact use case that I want to study. Then we have the ability to do the same thing down here on the outlet. In this case, we're happy with the values we have set down there. So here we also know the exchange coefficient and the ambient temperature for our aluminum heat exchanger. So very quickly go through there to find those different values for our heat exchanger. And so now once we've added all this in, we can then define the mesh for the fluid flow. Again, that's not something that I need to go through and manually do. Creo actually is able to build out that mesh for our model automatically. We can simply open up that grid, make sure that everything looks how we want it to. And so observing it here, obviously any areas where we're going to have more of a flat geometry where it's not changing as much, we can spread out that mesh a bit, and anywhere that we might be seeing a little bit more complexity, a bit more curvature, we can refine the mesh there, and we have options to go through and mess with that if we need to. Right, and so everything looks good, and essentially we can go through and run the simulation now. And once we do that, we're immediately getting data back from the study. So I'm able to make changes to the animation style, putting it into a form that best displays the information that I want to see. And also looking at the plots down at the bottom, you can see that the max temperature is settling out just under, say, 360 degrees Kelvin. You can also see that for each iteration that we go through, our plot information is being updated real time. And again, setting that up took less than 3 minutes to go through and do. We're really getting results back that fast. And so go through, analyze anything that we want to do. And once the simulation is complete, we can see that the water up here is coming into the heat exchanger at its highest temperature. And you can see as it's moving throughout the exchanger, it's cooling down by the time it gets to the outlet. So everything seems to be working as intended. We can also analyze our other outputs, such as pressure, to see exactly how that's changing over the course of the flow. And maybe also we need to see the effect of the temperature on the outer casing of the heat exchanger as a result of that flow. So again, it's great insight, really gives us a much better understanding of what's happening throughout that process. One of our other useful tools here for analyzing the results is the ability to take section views of these different results. So say we want to take a look at temperature values inside of our model. Well, move that to the X plane, also in the Y, and even in the Z plane. Another powerful tool that we have at our disposal is also the ability to search for specific values throughout the simulation. And so we have our first slider bar here that we can move around from a minimum to maximum and see what those values are right on the model. And also if I wanted to see everywhere, for example, if we wanted to see 345 degrees Kelvin, I can type that in and see right what that looks like on the model. Okay. So at this point now, it looks good, but maybe now someone from my team might send over a new version of the model that I'm working on. And because, as I mentioned, we're likely using this tool throughout the development of our parts and assemblies, this is likely to happen. So we can see there we have more of a lattice type structure, which is likely to change how the heat exchange is going to work. But instead of us having to go through and set up a whole new study, let's open up and utilize that one that we just created. So to do that, we'll go through, update the study to recognize some of the new geometry that we added into the model. And let's also update the surface sets to include some of the faces around both of the inlet and the outlet for the flow. And finally, we can go through, hide the CAD bodies, and utilize the mesh and the plots that we already have set up, and simply go through and run through the analysis. And then again, as soon as we click to run the analysis, we're instantly starting to get meaningful feedback. So we can change any of the properties of our flow to get it into a form that makes the most sense for us and our study in particular. And so now looking at the flow animation we have here on our model, we can see how those lattices certainly made a difference in terms of the direction of the flow, probably spread it out a little bit more and get that gradient. And also looking at our plots at the bottom, we can see things are starting to slow down, starting to converge around particular values. Okay, and so then we can go through and see, again, once that simulation is there and complete, go through, observe the flow a little bit closer, click through, change the animation properties, see what we're concerned with. Again, there it goes through, see if we have pressure values changing and see what that looks like. Obviously, it looks a little bit different than our first example there. And now our temperature values are more spread out, and now our heat exchanger is working a lot better than even we thought it was in the first place. And so that's a good look through that example there. And now we can talk about a little bit more about moving forward with this type of analysis tool and some of the real value that it does provide moving forward. So to start, now that we've seen it in the context of Creo, you can really see how we're working more towards that analysis-driven design. Because now if we have changes, we want to make new features in the model, we can still run those studies differently, and we can run them earlier in the design process, really shaping the ideas that we have moving forward. And that's really because we're able to break our dependence on those late stage physical prototypes, and first reducing the cost and also things like time to market. That's really due to the fact that we've gone through many more iterations and many more trials earlier on in the process. So there's no need to stack them all up and do them all at the end. And what that really boils down to is we're now creating and innovating at every stage of the process. And the products that we're creating are going to be coming out at the most high quality as possible. Right, and so that's our general overview. And one thing I do want to talk to now is we offer different packages around this. So depending on the level of detail or the different options that you might require for your particular process. So to start here, if you're focused more on just the flow, even things in with the heat transfer, looking at a turbulence, the base flow analysis might be your best bet there. So it's really still going to give you a lot of those different capabilities. And then next, if you want to do things like analyze the elements, such as actual individual particles or radiation, you might choose then to move up to the plus package. So this also gives you the ability to simulate the movement of individual components, and then along like we saw there with animating the analysis even while it's running. And finally, if you're going to be working with things like dynamic models or multi-phase or multi-component systems, that's when you would want to utilize the premium package. So get capabilities for cavitation, simulating fluids and solids interacting. Really, this is going to be the complete fluid analysis solution. And so we can see some great examples of what's possible with this tool here right on the right. So these are actually something that we partnered with and worked with this tool with a company called Smerix to create that tool and bring it right into Creo. So if you're interested in seeing some different applications of the engine, they actually have a gallery over at smerix.com that you can go through. Has a lot of different examples for how the flow analysis extension can actually really be utilized. And so that's all I have to go over here, and I can pass it back over now to Rob to talk about some next steps here.
Cool. Thanks a lot, Paul. Good stuff. One of the questions that came in, Paul, was when you had mentioned like you got quick results in like 3 minutes. What is the average turnaround time for getting results? If I can paraphrase the question.
And it is a good question. And again, the answer really there is it does depend, depending on how you set up the analysis, how many different conditions that you want to look through, what your actual system or assembly all includes. But then again, that's really one of the things that this tool is really targeted around is compared to your standard tool of running through CFD, it's going to be a lot faster. And so, Bill, I don't know if you have any more insight in that sense, but that's just kind of the general look into it there.
Well, I would say the tool is best used very early in the design by typically non-specialists, which means you're trying to solve specific problems, like in the case of that heat exchanger, how many baffles do I need? You don't need high precision for that. But a job like that, you could set up and get meaningful results in probably less than an hour. Some of the jobs you're seeing here, with these movable geometry, these can take a lot longer, but they're harder problems. But typically, you can get 3 or 4 iterations a day into your design. That's pretty powerful. Save you months and months worth of screwing around in the lab.
That's true. Bill, what other insight do you have as far as the strengths for this? I mean, because right here it's that we have the graphic up or the slide up for the different packages. What are the strengths of this this software?
Well, what it does really well, and better than some of the older products on the market, is the creation of the fluid domain. We didn't spend a lot of time showing you this because it doesn't take long. Basically, you take a volume and plug it up, and it calculates the domain for you. In some of the older products, you would have to spend hours and hours filling gaps and fiddling with dimensions to get things to fit just right. And you don't typically have to do that sort of stuff with this tool. Another thing I would mention here is the example that we saw was an internal flow example, but this tool is also quite capable of doing external flow, which would include natural convection. So if you're designing something, maybe automotive or maybe something like an LED light, which does not have a cooling fan, it's quite capable of giving you good information on that. have to go in and define gravity, and it's not too much more complicated. You do have to define a computational domain, but there's nice tools in there to do it. It'll take you about 5 minutes and you're good to go. One thing I would comment on, though, is if you're doing things like lighting problems, the Flow Analysis Plus includes radiation. Now, we didn't do it in this current example, but we're talking here about basically infrared heat transfer, which actually uses a ray tracing solver. It's running basically two solutions in parallel. And that would be a good thing to get if you are dealing with high power things like LEDs. If you're doing designing valves and doing internal stuff, the basic tool works quite good. And the advanced tool is necessary if you have any parts that are moving, which is quite unique, actually, ability to design valves and pumps and things like that. So most users probably can use the Analysis Plus and be quite happy with it. If you don't need radiation, you might get away with the basic version. Depends on what you're doing now.
And that's true. It absolutely depends on what you want your end result to be. Another question that just came in is if we need a simulation of suction by flooded suction type pump to check if suction creates vortices, how would we do it with this model?
That's basically a cavitation problem. I think it would work fine. It does do multi-phase, so I think if you get cavitation, it will show you that. It will show vortices in general. And it's just a case of putting the right pressure on. Now, it doesn't care whether pressure is positive or negative. It'll handle it. But if you're dealing with very low pressure, then cavitation is the issue. It will do it nicely.
Next question is, do we offer a free trial? So free trials are tricky because you're using the software for the first time and you're kind of getting spun up with it in a short period of time. I mean, can we offer a free trial? We can absolutely give you a free trial, but what we'd rather do is, get you to talk with Bill and kind of give you a shortcut to a free trial or usage so that you can get up and running and using the software in a way, in a trial, using the software in a way that's going to make sense for what you want your outcome to be. Is that an accurate statement, Bill?
Yeah, an hour or two of training goes a long way in that kind of case. If you have to sit there and try to piece your way through it, you'll get there, but it'll take you quite a while. It's an easy tool to learn once you use, but it does take time to learn it. Not a whole lot, but some.
Yeah, so the answer to that is yes, we do offer free trials, but I wouldn't recommend just trying to it would be like learning to ski without taking a class or sitting in with an instructor. So we can be the instructor for you to help you have a successful trial of the product. Absolutely. Question, could you do the analysis for incidental needs by our firm? We might not use the product all the time. Absolutely. I mean, that's something else that we do at 3HTI for our customers for anything CFD or FEA. Bill is our lead analyst, and he's seen a lot in his years with us, and working with companies like NASA. He's worked with NASA, training them on simulation tools and helping them with some specific issues and problems. I think one of them was an issue with the weightlessness pool, Bill, and another one you said was vibration of rockets. So yeah, we could absolutely assist with any analysis that you need to run, because and to this person's point, you may need to use the software, but you might not need to use it all the time. So the you know, it's not necessarily the cost of owning the software, because it's not, you know, super expensive, but it's the fact that if you don't use it all the time, you might have to relearn how to use it. This is something that you want in the hands of people who are going to use this, you know, kind of frequently, at least on a monthly basis. But if you're only using it like maybe a couple times a year, yeah, we can assist you with that. Absolutely. So we got about 2 minutes left. So what I'm going to do is I'm going to take control real quick. Screen 2. So anyway, I want to thank everybody for attending. Here's our contact information. If you have any questions, you can email me. You can send an email to info@3hti.com. You can call me directly. You can respond to the email webinar invitation that you received. If you respond to those that email will come directly to me. So once again, I want to thank Paul Dye. Paul did a great job on the presentation and the demo. Thank you. Appreciate your time and your support of 3HTI. And Bill, you know, great knowledge as always. It's always good to work with Bill. So once again, if you have any questions or you need anything, feel free to contact us. And I'm also going to upload this recording to YouTube and send you guys a link so you can view it at your leisure. So once again, thanks everybody for being on, and have a great weekend and happy Valentine's Day. Take care.